Now let's talk about what is an upper bound of two elements. Okay, we are going to talk about upper bound in a poset. Okay, so A comma R. Okay, so we define an upper bound like this. C is called as an upper bound of A comma B. Okay, so let us write it as upper bound of A comma B. Okay, if there exists a C, or if we have A comma C and B comma C belonging to R. Okay, so if we have both A comma C and B comma C belonging to R, then C is known as the upper bound of A and B. Okay, now similar to the concept of upper bound, we have something called as a lower bound. Okay, so I am going to copy this and I am going to tell you what changes over here. So let's paste it over here. Okay, now we are talking about lower bound of two elements in a poset. Okay, so C is called as a lower bound of A and B. Okay, if there exists a element C, or if there exists two elements in R such that we have C comma A and C comma B in R. Okay, so C comma A and C comma B should be an element of R, and which basically means C should be related to A and C should be related to B. In that case, C is called as a lower bound of A and B. Okay, now expanding the concept of the upper bound, we have something called as a least upper bound. Okay, let's see what it is. Least upper bound, and we define it as C is the least upper bound, okay, of A and B if there does not exist a D. Okay, so I'm saying over here, if there does not exist a D such that D is a upper bound of A and B. Okay, and we have D comma C a subset of or an element of R. Okay, then in that case C is called the least upper bound of A comma B. Okay, so D should not be a D comma C rather should not be an element of R. Okay, if at all D is an upper bound of AB. If D is not an upper bound of AB, then there is no problem. But if D is an upper bound of AB and you have D comma C also present in R, in that case C is not the least upper bound of AB. The least upper bound of A comma B is also written as A join B. Okay, it is read as join of A and B. Okay, and this is equal to the least upper bound of A comma B. Okay, so if you have any confusion in this particular definition, just understand that negation of this whole statement is what? It is basically equal to, for all D, okay, we have already seen what is the negation of an existential quantifier. So it basically means